Okay. So we're going to talk about two things today. First thing we're going to talk about is what we will initially describe as clock arithmetic. I'll give you the proper math name later. But here's why we're starting here. If it is 8 o'clock, what time will it be in 6 hours? 2 o'clock. How'd you get that? You add 6. If I add 6 to 8, I get 14. Okay. Right. Now, if it's 7 o'clock, what time will it be in 14 hours? Okay, and how 9? How did you get that? It would be, I'm sorry? Right. So in our system of clock arithmetic, adding 14 hours is just the same as adding 2 hours. And we all sort of know that from having used clocks a lot. Okay. So let me ask you this one, a little trickier. Starting at 9 o'clock, you're scheduled to take 3 3-hour tests consecutively. At what time do you finish? Okay, so how do we figure this out? Oh, okay. So we could do 9 plus 3 plus 3 plus 3, or as we learned in elementary school, it's another way to do this. Sorry? Oh, okay. Oh, you guys are coming with all these little clever techniques, sure. Now, why do you say subtract 3? Alright. So that's actually really, really clever, and it's correct, and we're going to come back to that later. The idea that, so first of all, you have to realize that we're adding 9. And how can you get the fact that we're adding 9? Well, 3 3-hour tests, 3 times 3 is 9. So the straightforward way to do this is to say 9 plus 9 is 18, but we know that we don't have 18, so what we're really doing is how many hours past 12 is it? It's 6 o'clock. Now Jonathan says something really clever. He said that, well, 9 is just 3 short of having 12, so instead of adding 9, it's the same as subtracting 3. Does everybody see that? Okay. So that's a really clever point, and we're actually going to come back to that in a little bit. Alright. Starting at 10 o'clock, you take 3 5-hour tests. At what time do you finish? Okay, and how did you get that? Sorry? Is that good? Okay. So, yes. So there are 2 different ways to do this. And the better one is the way you recommended. So notice that you could either simplify it in the middle by saying adding 15 hours is really on the clock the same as adding 3 hours. So you could make that simplification in the middle, or you could just do it the way you did and make the simplification at the end. Your way is better, I think. Okay. So far what we've seen is using a clock, we wrap around after 12. Next, we're going to wrap around after whatever we want. And that's the idea here. Okay. So, the general mathematical name for what we're doing is called modular arithmetic. And the abbreviation for that that's often used is mod. So, yes. Oh. Which part? Over here? Okay. So, yeah, I'll just stick with what Terrell said, which is if you take 3 5-hour tests, that's 50. Okay. All right, so you get it. All right, good. Okay. So the name for this, you can pick it up later. Name for this is, as I said, modular arithmetic. We often just say mod. Okay. So how do we say this? So on the clock, what we're doing is called mod 12, which basically means that groups of 12 just go away. All right. So how do we count in mod 12? Well, in mod, we're going to make one small adjustment to make it actual math as opposed to on the clock. When we do mod arithmetic for real, we don't count 1 through 12. We actually start at 0 because we want to have 0. So imagine there was 0 on the clock, and then you're exactly there for modular arithmetic. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 0. Okay. Now when we quote-unquote knock out those 12s, we call that reducing. Or one thing you can call it is reducing, actually finding the congruence class. Okay. So for example, using mod 12, 14 is equal to 2 mod 12. And that's one of the things actually that we just said in one of these problems. For example, when we said starting at 8, 6 hours later, well, 8 plus 6 is 14, but in mod 12, 14 is just the same as 2. Does that make sense? Okay. So now instead of saying wrap around or using the clock, we're just going to say mod. And we're using a clock, it's mod 12. Okay. So, and when you make mod statements, people use 2 different symbols to say that things are the same. You can use the equal sign, which is the thing that you've always done, or you can use this sort of equal sign and a half. So if you just want to say equals, that's fine. Another technical math term for this is to say congruent. So instead of saying is equal to, you could also say is congruent to. I'm not going to make a big deal about that though, so either one is fine. So you'd say 14 is equal to 2 mod 12, or you could say 14 is congruent to 2 mod 12. So now I'm going to introduce you to another kind of mod. Let's talk about mod 5. So how do we count in mod 5? So first of all, let's start at 0, so then how does it go? 0, 1, 2, 3, 4, 0. Okay. And you can reduce any number by subtracting 5. So for example, 17 is equal to what mod 5? Okay. It's equal to 12, and then what is 12 equal to? Right. It's equal to 7, which is then equal to 2. Okay. So what we did here is we reduced a bunch of times. Typically, we usually use, when we talk about working in mod 12, or in this case working in mod 5, we usually try to use the primary representative, and the primary representative is anything 0 through up to the number. So generally when we say reduce, that means knock it down to 2. Okay. So how do we write this out? So here's the thing that we said before, but just written in fancy math terminology. 8 plus 6 equals 2 mod 12. Okay. Now 2 plus 4 equals what, mod 5? This is 1, exactly. Okay. What about 4 plus 4 mod 5? Okay. Now, what about 4 times 3 mod 5? Yeah. Okay. So you guys knock those out. Okay, so let's talk about how these go. What is the first one? Okay, and how did you get that? Okay. Right. So this is 20, and then that reduces to 6. Right. Okay, good. What about the next one? Yen, how'd you get that? Right. Okay. And then the last one. Oops. Okay. Is 2. And then where did the 2 come from? Yeah. 3 times 2 is 6, but then you just do 6 minus 4. Okay. So, is that straight? Okay. So, a quick comment. So, in that first example y'all just did, one of the things you had to work out was what is 20 mod 7? So what do? Well, 20 divided by 7 equals 2 with a remainder of 6. So what does that have to do with mod arithmetic? Sorry? Yeah, that's exactly it. Mod is the same thing as remainder. Now something else, thinking about remainders and thinking about how we count in mod arithmetic, what does this remind you of that we've already covered this semester? Well, for example, in mod 5 we count 0, 1, 2, 3, 4, and then we go back to 0, 1, 2, 3, 4. What does that remind you of? Yeah, bases. This is closely related to working in different bases. So mod 5 is the same as base 5. Now it's not the same, I'm not saying that, but it's related. Okay. So these are related. Okay, so next bit is to talk about, so we've already talked about addition and multiplication. Now we're going to pick it up a notch and talk about first subtraction. So how do we do subtraction? Well, what's 5 minus 2 mod 8? 3. Well, that one's easy because you do 5 minus 2, you get 3, and then you're done. There's nothing interesting to think about. Now what? What is 4 minus 7 mod 8? Well, 4 minus 7 is negative 3. What does that mean? Yeah, if you think in mod 12, yeah. You're exactly right. Yeah, and how'd you get 5? What? You don't know? I think you do. Right. The negative 3 is this, just like everything else in mod, you can always add or subtract 8s and you get something that in mod 8 is equivalent. So if you have a negative 3, we reduce not by taking away 8s, but we can reduce it by adding 8s. So if you add 8, you get 5. Okay. So there's another way to think about negative 3. When we first learned negative numbers, what do we learn that this is? We learn that this is on the other side of 0. So this is 3 less than 0. Well, let's count, in mod 8, count 3 back from 0. And what do you get? 0, 7, 6, 5. That's another way to think about it. And that way is, I think, pretty closely related to what Jonathan said earlier. If you're on a clock, which means mod 12, and you're adding 9, that's the same as subtracting 3. So, Jonathan, do you see the connection? Okay, does everyone else see the connection? Alright, so I see some nods, but also for everyone else, I guess think about it a bit. Okay. So I have a bunch of stuff here, but we've already talked about it. The thing that I want to point out is this last line here. So first of all, we know that mod 8, 5 is the same as 13, is the same as 21, is the same as 29. Those are all the same mod 8. They would all just reduce to 5. But we can also go the other way. 5 is the same as negative 3, is the same as negative 11, is the same as negative 19, is the same as negative 27, etc., etc. So now we have a way of understanding negative integers and negative numbers in mod arithmetic. So why don't you guys do this one? Okay, so yeah. The first one is yeah, and how'd you get that?
Subtract 5 from 2 and you get negative 3.
Uh-huh.
And add a 6. So negative 3 plus 6.
Right. And that's your answer. There you go. Okay. And then what about the, so very good. So what about the next one? Okay. So what do we do? Well, minus 8 is negative 7. It's 2. And there you go. Okay. Okay, good. So any questions so far? Okay. Good, because now we get to what's kind of the hard part. Why is this going to be hard? Okay. Well, first I'll start with the easy stuff about division that we know. 12 divided by 2 equals 6. We all know that. Okay. Why? How can you justify to me that 12 divided by 2 equals 6? Right. So there are two different so the two things that you guys just said, those are the two ways to think about this. On one hand, you could say, well, we know that 6 times 2 equals 12. We could also say that if you were to think of having 12 and to group it into 2s, there'd be 6 groups of 2, or if you divide it in 2 groups, there'll be 6 in each group, either way. Okay. Well, what if you said, what is 6 divided by 5 mod 7? Can we take 6 and say, let's break it into groups of 5? No. This doesn't work, because remember, in mod 7 we only have 0, 1, 2, 3, 4, 5, 6. So we're not dealing with fractions here, so this isn't going to make any sense. So for division in mod arithmetic, we're not going to be able to think of grouping. So we're going to have to only be able to use the other way. And the other way says, what times 5 gives us 6? Right? In the same way that when 12 divided by 2 equals something, we said 2 times what gives me 12. So this is the way to think of division in mod. Okay? So now it turns out that 4 times 5 equals 6 mod 7. In fact, we just did this problem. Four times 5 equals what mod 7? You guys just did it. So 4 times 5 equals 6 mod 7. Yeah, I'm clever. I set it up like that. Okay. So knowing that 4 times 5 equals 6 mod 7, we can now say that 6 divided by 5 equals 4. Mod 7. Now remember from when you first learned division, since we know that 4 times 5 equals 6 mod 7, we have 6 divided by 5 equals 4. What other fact do we know? What other division fact do we know? 6 divided by 4 equals 5 mod 7. Now, of course, make sure that you write down mod 7, because if you simply write down 6 divided by 5 equals 4, your elementary school math teacher will come and hunt me down. Okay. But mod 7, this is absolutely correct. Alright. So this is very disappointing, because the only way that we can do division is to somehow magically know multiplication first, and in fact magically know the right multiplication first. So for that reason we don't do division that often, but when we do, we make a chart first. So in other words, in order to do a division problem, we have to know every multiplication problem first. Either that, or we just have to be incredibly clever. So I'm going to switch to mod 5, and we're going to do this, and we're going to do it in mod 5. So we're going to make a table, a multiplication table. Okay. And I've taken the liberty, excuse me, since we seem to have a good handle on doing multiplication, I've taken the liberty of already filling everything in. So just take a quick note, for example, 3 times mod 5, 3 times 3 equals what? mod 5, what do you get? 3 times 3 is 9, but what is that mod 5? It's 4. Okay, so remember we're doing mod arithmetic. Okay. So now we don't even have to look. Now we don't even have to think about it. We've got the entire table right there with every possible multiplication written out. Okay. So now use the table to answer these questions. Mod 5. 4 divided by 3 equals what? Mod 5. So how do we answer this question? This is the same as asking what? What times 3 equals 4? Exactly, mod 5. So 3 times what equals 4? 3 times 3. So the answer is okay. So 2 divided by 2 equals what mod 5? Hint, it's easy. Right. Why is that one easy? Because you can just do 2 divided by 2. Psych. Okay. So now let's get back to the more challenging problems. Okay. 1 divided by 3 equals what mod 5? So how do we do this? So this is the same as asking okay. So now where do you look on the chart in order to figure this out? In the sorry? Absolutely not. So I prefer to think of this as 3 times what? I suppose sorry? You're looking at 3's. And? Right. This means you have to look here where there's a 3. Right? Does everybody remember how to use a multiplication chart? Okay, great. So 3, now usually we would just do 3 times a number and then look for the result. But we're not doing multiplication. What are we doing? We're doing division. So we already have the answer. What's the answer? 3 times what equals 1? So the missing number is 2. So the answer is 2. Okay. So in particular, notice that we know that 1 divided by 3 equals 2 mod 5. And what other division fact do we also know now? Something divided by something. Sorry? No, we know that 3 times 2 equals 1. One divided by 2 equals 3. Mod 5. Okay, so you have to throw out your basic notions of counting. You have to remember what it means to multiply. You have to remember how multiplication and division are related. Right? We have to think of division as the opposite of multiplication. We cannot think of division as grouping, as I said before. So when you have, for example, if you have 3 times 2 equals 1, what can you do to this statement? You can divide by, so what we wanted was 1 divided by 3. So now I hate to write it like this, but you write it like this. And then the 3's cancel and you get 2 equals 1 over 3, but really we should think of it as 1 divided by 3. Does that make sense? And similarly, we could also divide by what number on both sides? All. We've divided by 3, which will cancel the 3's. We could also divide by 2. And when we do that, the 2's cancel, and what you're left with is 3 equals 1 divided by 2. So again, I wrote it as a fraction. Don't think of it as a fraction. Think of it as just division. And of course, all these things are in Mod 5, because those are the facts that we're using. Okay. You dig? All right. Yeah, they're equivalent, right.
So if you have a big number, 12, divided by
yes, and what do you have to do? If you start with, for example, 12, if you start with, say, 12 divided by 7. Or, no, that's not going. 12 divided by, that's not going either. 12 is not a good number. Too many things go into it. 13. 13 divided by 6. What do you have to do? How many times does 6 go into 13? No. Not in mod arithmetic. What do you have to do? Yeah. So if you're asked to do 13 divided by, 6 isn't good. If we're going to work mod 5, let's make it 13 divided by 7. There you go. Mod 5. Okay. What do you have to do before we can even start to think about doing this problem? You have to reduce it. So 13, mod 5, 13 is the same as what? Yeah. So 13 is really 3. Actually, let me just do it like this. And then what is 7? 7 is the same as 2. And now you can go ahead and do this problem. So the whole thing is that typically we wouldn't write 13 and 7 mod 5, but if heaven forbid somebody threw this curveball at you, this is what you have to do. You have to say, well, 13 isn't the number we like to use in mod 5, what number should that really be? Is it? Let's take a look. 3 divided by 2. Yep. Yep. So this is saying 2 times... oh, wait a second. 2 times what gives you 3? Right. Mod 5. That's 4. So 13 divided by 7 equals 4. Mod 5. Sorry? Okay. So 2 times what equals 3 mod 5? Let's look at the chart. 2 times what gives you 3? Here's the 2, and we want the answer to be 3. Want the answer to be 3, so the answer is 4. The number that we're looking for is 4. Okay. So, right. Remember that multiplication and division are opposites. Or in math we say inverses. Okay, so you have to remember that as you're doing these problems. The only way, as I just said before, the only way that you can do division is to think of it as the inverse of multiplication. But when thinking of it as the inverse, you have to remember what the inverse means. And that's what we're just talking about right here. 3 divided by 2 equals some number is the same as saying 2 times some number equals 3. And the question is 2 times what number gives you 3, and you have to look at the chart. Okay, so I think as you can see that addition is fairly straightforward, multiplication is fairly straightforward, subtraction isn't too bad, division is a little tricky. So I think the best way to deal with that is to try to work out some examples in the homework and see if you can work it out that way. But aside from that, any other questions?
But if you had like mod 6 or 7, you have to make the chart of the...
You'd either have to make it or it would be provided for you. Right. Who knows? We'll see. Is there? Can we do mod 13? Why not? Can we do mod 48? Sure, why not? The only restriction is that it has to be a whole number. You don't have to make a chart, except that I would say for division, there's no way to. There's no reasonable way to do it except with a chart. Yeah. But if you're just doing an addition problem or a multiplication problem, those we saw we just did straightforward. Any other questions? Okay. Let's take a brief break to let your brains soak this in, and then we'll get on to the next thing. Alright, so let's go.